In this proof, we're being asked to show that sine of x divided by 1 minus cosine of x is equal to 1 plus cosine of x over sine of x. So one thing that I want you to notice is we kind of have things moving from numerator to denominator. This sine of x up top has to go to the sine of x in the denominator. 1 minus cosine of x needs to move to the numerator, and it has to turn into 1 plus cosine of x. So what we're going to do here is actually a move called setting up a Pythagorean identity by using a little bit of algebra. What we're going to do is we're going to take our given, sine of x divided by 1 minus cosine of x, and we're going to multiply the numerator and the denominator by the conjugate of the denominator. Now, the reason why I want to do that is because I want to create a Pythagorean identity in the denominator to get this 1 minus cosine of x to go away and turn into a factor of sine of x. So if I do that, now I multiply, I have sine of x on top times 1 plus cosine of x, and I'm not going to distribute that, I'm going to keep that in the factored form. The denominator, I have 1 minus cosine times 1 plus cosine. I'm going to go ahead and FOIL that. That's going to give me 1 minus cosine squared x. So notice what that does. That gives me that 1 plus cosine of x that I want in the numerator, and that's creating a situation where I'm going to be able to get some signs in the denominator. So up top, again, I'm going to keep that in its factored form. And then we know by the Pythagorean identity, 1 minus cosine squared is equal to sine squared x. So then, what happens? The numerator has a factor of sine of x. The denominator has 2 factors of sine of x. So we'll be able to cancel a common factor of sine of x in the numerator and the denominator to give us what we're trying to prove. 1 plus cosine of x over sine of x. So here we are multiplying by the conjugate to set up a Pythagorean identity.